So I actually discovered in a mathematic discovery under how dominoes behave, especially when it turns around. Um, I'll probably post a full video on it, but this is just an overview on how it's made. So as you can see, there are two main paths. One goes at this direction, others goes into that direction. And you might be thinking, how did you get this kind of space? And also on the identical setup, how do you also get this kind of space? Well, to answer the question, this one refers to the general distance, and this one refers to, this one refers to the sensitive measure, and whereas this one refers to the general measure. And I actually discovered this from physics and mathematical methods. Now, keep in mind that I am not good at physics. I took physics class in high school. I did not do well, despite having very strong mathematics background. But it does involve with vectors, and this is how it is made. So, this is given that the domino travels at n degree offset. So as you can see, there is a D1, which is one domino path, and D2, which is another domino path. And n denotes the degree of an offset. So as you can see here, those two, this right here measures 45 degrees in this direction. But the reality here is that it tries to take the opposite direction. So we reverse it D2 arrow. Now we need to calculate the resulting vector of D equal D1 minus D2. And this is a footnote here. I'm not good at physics, but this involves vector. And I also discovered the speed, which will be covered later. Now, for the sake of brevity, denote speed as s. So, since the domino weighs 8.5 and the speed is 72.19 centimeters per second that I calculated, the idea here is that we want to calculate the momentum. So if you have a higher momentum, it's difficult to change direction. Since momentum equals mass times velocity, what I have is D1 equal P 8.5 S, and this one has the I and J vector denoting the horizontal vertical vector. So the idea here is that D1 just only travels at the horizontal line, so it doesn't change. But D2, since we have to take the negative direction because of how it actually perceives, we got negative 8.5 S cosine of n. Keep in mind, those right here scalar, but not the I and J. And this one's also the scalar. Then we add those two vectors up, P1 plus negative P2, and this is what we got. Now, we find the magnitude here, and we got 8.5 times the speed constant times the square root of 2 minus 2 cosine of n. Then we find a direction, and here I got negative 90 plus n over 2 because it points southeast. So this means the cosine would be positive, but sine would be negative. Actually, no. This means that the horizontal will be positive, but y direction will be negative. So, since mass is scalar, I thought of dividing the momentum that we got, the scalar momentum divided by the mass. So, in this case, we got the speed of s constant, speed constant times square root of 2 minus 2 cosine n. Now, here's another idea. Remember the video that I posted? That we discussed how far the last domino travels. So by considering the last domino length, it uses two large edge length for sensitive setup and one large edge plus one medium edge length. If you now know, this one is the large edge, this one is the medium edge, and this right here is a small edge. So as you can see here, I made two equations, the proportion. So this refers to the speed on the numerator and the specific length on the denominator. And there are two equations. The first one, as you can see here, is for the sensitive setup. The second one is a general. And I got this, and keep in mind that there is a half angle trig identity. And this is what I got. Now, since the domino is in its way, which means that if you have this, you cannot like get into the center right over there. So you need to accommodate with its spacing that gets in between. We subtract 1.125 centimeter, and we got this. So this is a mathematical formula that I discovered, and keep in mind that rounding up is necessary. And the idea behind this is that sometimes you could get the proportions that is not in the whole number system. And because of that, this is what I got. Now, the applications for this, that if you want to do this condensed setup, domino setup, then you will need to consider its spacing. Otherwise, you can accidentally touch or tamper the other domino's tricks path or the normal path. And I have been experimenting this, and at this point, sometimes my calculations may not be completely correct, but it gives you a visual representation of how spacing should be considered. And I will probably discuss it a full video on this, but this is just an overview. I'll see you guys.